the very last thing we have when it comes to sight is eye movements. And we have three types of eye movements. Again, these are all going to be controlled by the extrinsic eye muscles: superior oblique, inferior oblique, superior rectus, inferior rectus, medial rectus, lateral rectus. Okay, so those are our six, and those are our cranial nerves that supplies them. Lateral rectus 6, superior oblique supplied by cranial nerve 4, and the rest of them are supplied by cranial nerve 3. These extrinsic eye muscles give us three types of movements: saccadic eye movements, smooth eye movements, and vergence movements. It is these three movements that are always happening. You don't really know you are doing them. Well, you know you're doing vergence. Vergence movement allows both the eyes to follow something as it gets close. Allows both eyes to converge. I'm going to change that color. Sorry about the color. Allows both eyes to converge on an image. Okay. Both eyes look at it. Both eyes converge on it. And we get that to focus on the fovea, right? The fovea centralis, again, that's where our greatest visual acuity is. Smooth movements is just allows us to, follow a moving object and stay in speed with it. So, or your eyes, where to go? Okay. And saccadic eye movements is what the eye is always doing. It's always moving all over the place, and we necessarily don't know because they're really quick, high velocity movements. But they allow us to focus the image on the fovea centralis. This is what happens when we read, okay? As you kind of go, and sometimes you don't even know that the eye is moving, okay? Because it's just, even though these are skeletal muscles, and you know how to read left to right, you're not saying, okay, contract on this side so I can, you don't say that. It's just high velocity movements that just automatically happen. All of these are required for normal vision to occur properly. The last thing we have is pupillary reflex. And the pupillary reflex is what happens when you shine the light in the eye. When you shine the light in someone's eye, that pupil start to constrict, right? Well, that allows us, there's a special photopigment. It's called melanopsin. Melanopsin is what allows the pupillary reflex to do what it do, basically. It allows us to determine the brightness of a light. So, as a light is far away, and as it gets closer, it gets more intensity, greater illumination. And it's that melanopsin within those ganglion cells there within the back of the retina that allow this pupillary reflex to protect the eyeball and not have it be so painful. And that's parasympathetic. Remember, sympathetic is going to vasodilate, good gosh, open up the eyeball, open up the pupil, and to bring in as much light as possible as you fight off your attacker. It does work with the suprachiasmatic nucleus in the hypothalamus in regards to circadian rhythm. So it'll help you, it'll help the process of being asleep when it's dark outside, and when it's awake, when it's light outside, you're awake, which is going to go hand in hand with the pineal gland. Suprachiasmatic nucleus, pineal gland, circadian rhythm, it is all connected with one another for those. So the pupillary reflex does a lot of fantastic things. In a clinic setting, you check it, you divide both sides, you have a bright light shine in the eye, look at this side, you'll notice that this one will, if you're shining the light into this eye here, the pupil will constrict really quick, and then look over here, and then it will respond. And then you shine the light over here on this side, this one's quick, and then this one's a pause before it starts to shrink. So it helps to keep them both equal, so it can help form a better image in the back of the eye. If for some reason this one, let's say the light's being shined over here into my left eye, if this pupil does not constrict down, then something's wrong, and you got to figure that out. What's going on? Is it something wrong with the eyeball itself? Is it something wrong with the muscles there in the eye? And you just need better glasses? Is it something involving with the occipital lobe, where the primary vision cortex is in the brain? So you got to try to figure that out. But the pupillary reflex is just another reflex to test for cranial nerve involvement, excuse me, and to test for, swelling and inflammation in the brain.